Here we go. All right, so problem 17, homework 2.2, page 72. We're taking this quadratic. We're going to do a few things. Yes, ma'am.
Is that 0.5?
Yes, it is 0.5. 0.5x squared minus 2x minus 4. And we got to find some things. The first thing is that we need to determine, does it open up or down?
Up.
So is the smile opens up, right? So because it's positive, right? Because this is positive out in front, it smiles. Okay? All right. So we know that it opens up. Okay. Secondly, find the axis of symmetry. That's the first step that we use. Okay? Remember, f prime of x is equal to 0 is your axis. In other words, 2ax plus b equals 0. You use one of these. I don't care which. Okay? You use one of them. Remember, this is A, this is B, this is C. Okay? It's really easy to do because the derivative is what we're going to be doing in calculus. Okay? The derivative is just the exponent times the coefficient. What's 2 times 0.5? What's a half times 2? Half of 2. 1. Okay? So that's 1x. Okay? Then you take 1 away from the exponent. So I take 1 away from 2 and I get 1. That's what the derivative is. Okay? So for us, these are going to be on quadratics, right? And so you're always going to be doing 2 times the coefficient. 2 times the coefficient, every single time. 2 times the coefficient. So you'll have 1x, and then what's 1 times negative 2? Just negative 2. And then solve. Make that equal to 0. Okay? Again, the reasoning behind this is that dy over dx, in other words, is the change of y over the change in x. Do you guys remember what that was? You guys remember what? It was m. Good. It's a slope. That's exactly what it is. And that's what a derivative is. The derivative is the slope of the function. Okay? If we think about this function, right? And we think about this slope. Is this slope positive or negative? Negative, right? Is this slope positive or negative? Positive. And at some point, it's going to change to be 0, right? And at that point, it's going to be at its lowest point on the function. That's where it changes from negative to positive. There has to be a 0 in between negative. Take a look. I see you guys shaking your heads. Don't just shake your heads. Look at me. This isn't hard. There's going to be a point at which you have a slope of negative or a slope of positive. At some point, that slope is going to become 0. Do you see that? Right? At some point, before it goes back up, it's got to be at 0. That 0 slope is going to be at the lowest part of this graph. Okay? So wherever this thing comes down and gets that last point, that's when the slope is 0. That's why we're finding the derivative of 0. Okay? The derivative of 0 as it's coming down and going back up. So right here. Okay? That's the 0 slope. At the 0 slope, you're at the lowest point on the graph. that lowest point on the graph is what we call the vertex. Okay? The vertex is that lowest point where everything on this side is symmetrical to everything on that side. Yes? Exactly. So the vertex is, in this case, the minimum value, right? Because we're talking about a minimum, right? So if it opens upward, then we're talking about a minimum, right? The lowest point. If it were to go upward, right, open downward, then we would be talking about a maximum, okay? But the only thing this solves for is x. All it solves for is x. It doesn't tell you why, right? So the only thing it's solving for is the x equals. Okay? So when we solve for this, we know what x is, but we don't know what y is. Okay? That's why we don't have a vertex, because the vertex is a point. It's a point of x and y. We only have x, and that's why it's called the axis of symmetry. It is where the function is symmetrical on both sides. So I could fold it like a piece of paper. And if I fold it, it would land on itself. Okay? That's all it means. Big fancy words. Stuff you haven't seen before. But we're going to get through it. Okay? Alright, so we're going to solve this. We can solve this. We've done this plenty. What do I do to solve this? Add 2. So I get x is equal to 2, right? That's it. That's your axis of symmetry. That's what x is. When the slope is 0, x is 2. That's all you're saying. When the slope is 0, x is 2. And that's the axis of symmetry. Okay? So the axis of sim is x equals 2. Alright. So we have a little bit more, right? These are big, 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 big problems. Okay? Now we got to find the vertex. But think about it. We just said that the vertex is that point, right? We found the x. Right? So what we got to do is find the y, right? To find the y, do you remember y is f of x, right? So all we got to do is plug it in. So step 2, right, is f of the axis is equal to the vertex. In other words, plug it in. That's it. Just plug it in. Okay? So I take this formula, this function, right? F of x. And I say f of f of 2 is equal to 0.5x squared minus 2x minus 4. So in other words, x is 2, so the 2 goes in for x. That's it. We're just plugging it in. This should have been fifth chapter Algebra 1. Right? 5th chapter Algebra 1, we do quadratics. Or actually, 6th chapter Algebra 1, we do quadratics. And we start plugging it in. Okay, what is 2 squared? 4. Okay? So 2 squared is 4. Okay? What's 2 times 2? 4. Okay? What's half of 4? 2. Okay. So 2 minus 4 minus 4. Now remember what I said. We know we're on the right track if what? if one of these is half of the other, right? Is 2 half of 4?
Yes.
Then we're on the right track. That's the beauty of it. You know you're on the right track. You know something is wrong if you have 18 and 2. Okay? So something went wrong, redo it. Because they need to be halves. Okay? Now nobody ever taught me that. And it's not taught in the book. This is a pattern that evolved as I watched it happen over the years. I even talked to Jeff about it, and he was like, "Does that really happen?" And I'm like, "Yes, look, every time." And he's like, "Holy crap!" It's like people don't see the easy pattern. The easy pattern is they're always halves, always. Okay, so that means I know if I'm right or I know if I'm wrong. Okay, I don't know. Okay, so then what's 2 minus 4?
Negative.
-2. Okay, and then we got -2 minus 4, which is -6. So at f of 2, it equals -6. And this is the reason why we use f of x. Okay, because I can write 2, -6 as a quadrant, as a coordinate. Okay? This is my vertex. So they ask for the vertex, and we know that the vertex is 2 and -6. Alright, so they don't stop there. They ask us more. Find the y-intercept. Well, guess what my third step is?
You're not erasing anything else.
I just erase things I don't really need. Alright, what is my third step?
Find the y-intercept.
Yeah. Find the y. It's pretty simple. First, axis of sim. Okay? Second, vertex. Third, y-intercept. So the y-intercept, how do you find it? You plug 0 in for x. When you plug 0 in for x, you always get c. No matter what. Every time. Every time I get c. Whatever that last number is. So in this case, f of 0 is equal to -4. That's not hard. This isn't bad. So the y-intercept is -4. Okay? I'm going to write this as a point. 0 and -4. The reason is I'm going to get 3 points. Okay? Then I'm going to graph those points. I got my vertex. I got my y-intercept because it's the easiest point. Okay? And then my last point is the point of symmetry, right? The point symmetric to that y-intercept. And if you think about it, every time we do this, we got this. If it's on this side, if the y-intercept is on this side, then it's going to be twice as far, right? If this is half, then this is going to be twice as far every single time. And even if it's on this side, right, it's still going to be twice as far. It's always, because it's symmetrical, right? So it's always twice as far. So we take 2 times the axis. And that should equal C every time. 2 times the axis should equal C. And if it doesn't, something went wrong. So check it. Okay? This is your check method. There's 2 checks. Okay? One is in 4, and the other one is in 2. when we have halves. If they're not halves, something's wrong. And if this isn't equal C, something is wrong. So we plug it in. What is 2 times the axis? Well, the axis is how much? We said it was 2, right? The axis is 2. So we're going to go f of 2 times 2, which is f of 4. When we plug that in, we say half of 4 squared, right? Minus 2 times 4 minus 4. Okay. What is 4 squared? 16. What's half of 16?
8.
8. What's 2 times 4?
8.
8. What's 8 minus 8?
0.
So we get back to negative 4. Alright? So f of 4 should equal negative 4. So you get a point, 4 and negative 4. Okay? Now they don't ask you to do this. What they ask you to do is graph the function. Okay? They just say, okay, after the y-intercept, graph the function. Well, this is what I need. I need a third point. So now I can graph the function. I have 3 points. I have a vertex. 1, 2, 1, 2, 3, 4, 5, 6. At 2, negative 6, I have a vertex. Okay? At 0, negative 4, is that in red? At 0, negative 4, I have the y-intercept. And remember, this was our axis of sim. Halfway across, so at 4, it's going to be at negative 4, right? And that's my point of symmetry. So now when I graph this, I have a nice equation. I have a nice function. Okay? And we're going to be doing this a lot. Okay? Questions before I cut off the film. Because sometimes the questions are more important than the work. Questions? There's got to be a question. I didn't do it perfect.
Dan,
Yes, sir.
have you ever done drugs?
Oh, man.
Yeah.
Obviously.
In the 90s.
Long time ago, son. Long time ago.
What about hard
Not like a month ago.
We're on film right now, guys. We're on YouTube.
Hey, he told me
Can you stay after school on Wednesday?
Yes, we can stay after school.
to. Yeah, I was going to say that. Can you teach me how to cut?
Huh? Questions on this? Everybody, it made sense? No?
Does it make sense?
Working on it?
Well, you were